This is Pre-Calculus 12, Chapter 5.3. We're going to be solving exponential equations. And there's two choices. We can find a common base and then solve the exponents, or we can use a calculator, as in the previous section, or we can also use the table as well. When we're finding the common base, we need to factor and then solve using algebra. So here's an example. These are not common bases, but these have a common base of 3. This is 3 cubed, x to the minus 4, 3 squared, 3x. These are powers of powers, so we need to multiply the exponents. This is 3 to the 3x minus 12, and we have 3 to the 6x. So we're just multiplying. Now that the bases are equal, we can just solve for the exponents. 3x minus 12 equals 6x. Let's move the x's over to this side to keep everything positive. So negative 12 equals 3x, and x equals negative 4. Let's look at this problem. We have a base 5 here, we have a base 5 here, and this is also a base 5. So this is 5 to the power of 3. This is 5 to the power of 1/2. This is 5 to the 3x. When we are multiplying powers of the same base, we add the exponents. So 3 plus 1/2, that's 7/2. And this is 3x. And again, we can equate the exponents because the bases are the same. And divide both sides by 3. We have x equals 7 over 6. Solving word problems. We need to determine whether the problem is growth or decay. And we can tell if r is greater than 1 or r is less than 1 for decay. You need to determine whether you are given a change or a rate, and then figure out what the base is for the exponential function. The amount is decreased by 9%. This is a change because we're taking off 9%. So the rate is 1 minus 0.09. That equals 0.91. So 0.91 is your base. Remember, we have to divide this by 100. That gives us 0.09. The amount remaining is 0.89 after ... This is a rate. It says the amount remaining is. So our rate, and since this is already a decimal, that's a number, 0.89. So here we had a percentage, we needed to convert it to a number. Here we're already given a number, we don't need to divide by 100. There is 15% more after ... Again, this is a change. It says 15% more. So adding, decrease, this is subtracting. Here it's just is. So that's a rate. This is a change. So R equals, and we always start off with 100% unless we're told that we're starting at a different value. 0.15. So the ratio is 1.15. Again, this is a percentage. We need to divide by 100. So there are many ways to phrase the question, so read carefully. And we need to be careful about rounding. Don't assume rounding to the nearest is correct. Okay, for math problems, sometimes they'll say round to nearest, but in the business world, that's not always the case. Banks always like their pennies, and you may have to round up rather than round off. For compound interest problems, we have a of t equals a naught times 1 plus I over n, all to the power of n times t. And this is a single deposit and not regular investments. Okay, so this is similar to like buying a Canadian savings bond. You buy it at the beginning, you don't buy any more, and it earns interest. So interest rate, this is normally a percentage. So you'll have to convert it to a number. And if it's a percent, like it says, divide by 100. N is the number of compoundings per year. You should have an S, compoundings per year. So we have to divide the interest rate by N, and we have to multiply the time by N. So using this formula, you're going to get more money when you have more compoundings per year. How are compoundings expressed? Well, we have annual, that's 1 time a year. Quarterly, that's 4 times a year. Monthly, that's 12 times a year. Weekly, that's 52 times a year. And daily, that's 365 compoundings per year. In addition to these, we can add a prefix of semi or by. Semi means to double the compounding. And by means to halve the number of compoundings. Okay, put an S there. So, for example, semi-monthly, we double the 12, so that's 24. Bi-weekly, we halve the 52, so that's 26. Okay, let's look at some problems. An investment of $3,000 is put into a term deposit at 1.5%, which is compounded quarterly. What is the value after 2 years and 5 years? So we have to decipher this. This is our interest rate. So we call it IR when it's a percentage. And then when we divide by 100, I equals 0.015. 3,000, this is our A naught. And quarterly, this is our N, and it equals 4. And this is the number of years, so that's our T, and this is also our T. So we write our formula, A of T equals A naught, that's 3,000, 1 plus, we take our I, 0.015, and divide this by 4, and it's 4 times T. So if the question asks for a formula, this is your formula. Now we evaluate A of 2 equals 3,000, 1 plus 0.015 over 4 times 2, that's 8. And that's approximately 3,091.19. Okay, the bank will round off this figure. So rounding off is correct here. A of 5 equals 3,000. 1 plus 0.015 divided by 4. And we have 4 times 5. And this is approximately 3233.20. Let's just verify this on a calculator. 3,001 plus 0.015 divided by 4 raised to the power of 8. That's correct. The other one, we'll just edit this and put in 20. And that's correct. That's rounded up. Don't forget your units for these problems. This is a dollar sign. We have dollar sign here. We need dollar sign there. Another example, IR, I equals 0.045. Gets compounded annually, so N equals 1. How long will it take for the investment to triple in value? This is a number. Triple means 3. So our formula is A of t equals 1. So how much do we have initially? All of it. All of it means 1. 1 plus 0.045 divided by 1, that's just itself. And then 1 times t is just t. Now we go A of c, it could be any variable, equals 3. So after some times c, it will be triple, so 3. And we can leave out this leading one, and we combine these two, 1.045 and c. And we'll use a graphing calculator. Okay, so we go y equals 1.045 raised to the power of x minus 3. Put a minus here instead of an equals. That way we're looking for an intercept rather than an intersection. Okay, so we have to play with the window. We don't need negative values because it won't be negative time. So we'll put in 0. It wasn't going up very quickly, so we'll have to double or triple this. We'll say triple. That way we'll lessen the amount of iterations we need to take. And because this is 3, we'll just go -3 to 3, and that's good. And now we can graph. And there's our answer. So we'll do a second calc. We're finding a 0. That's good. And I'm just going to enter 30 here, since I don't want to scroll and guess. And we get C equals 24.96. Okay, so you have to determine whether we're going to round off or round up. If this value is lower, we still want to round up, because if we rounded it down to 24, we wouldn't have triple the value. So we have to round up. So we're not talking from a banker's point of view here. We're talking from an investor. You want triple the value, you have to go up to the next year. Okay, so we have that here. Again, if we look at 24, it's not quite enough. And at 25, it's tripled. So that's our answer. Now, an interesting generalization comes up. It's called the rule of 72. Okay, it's used to approximate the number of years for an investment to double. So if accuracy isn't important and we just wanted speed, we can figure this out. So how long does it take for an investment to double that is compounded annually at 5%? So we take 72 divided by 5. This gives us approximately 14.4 years. 72 divided by 5, 14.4. Double means 2, 1.05 to the power of x. We solve this on our graphing calculator. 1.05 raised to the power of x minus 2, and graph. Fortunately, that domain and range works for us. Second calc, and we want the 0. And the left bound, that's pretty close, so we can just scroll over, and hit enter twice. And it's approximately 14.2. So our estimate is only off by 0.2, and we did that rather quickly versus doing this. Okay, let's look at one last example. And we just recently had an eclipse this summer, so this is a relevant question. A filter will reduce the amount of light by 91%. A person wants to watch the solar eclipse, so the amount of light needs to be reduced to 0.003%. How many filters do we need? Okay, so our target value is 0.00003. Okay, so we have to add 2 more zeros when we're dividing by 100. R equals 1 minus 0.91, so that's 0.09. Okay, we divide the 91 by 100. So our exponential equation is yn equals 1. We start off with 100%, and it's 0.09 to the power of n. Okay, so we have yn equals 0.00003 equals 0.09 to the power of n, and we use our graphing calculator. It's tricky to set the window, so you just have to guess at some number of filters. And because value is so small, we need to go from 0 to a very small value. So this is 0.0001. Okay, so let's convert this to scientific notation. So this is 3 times 10 to the minus 5. So if we use our graph, we can solve it this way. And we get 4.3. And down here, to get to 3 times 10 to the negative 5, this is not quite enough. This is enough. Okay, we need to round up because 4 filters will still make you go blind. If you stare at the sun long enough during an eclipse. So, don't be like this guy staring at the sun without any filters. Being president does not stop you from going blind. And that completes this lesson.